Lesson 7 is on linear systems. This is the last lesson in this unit. A linear system is a set of two or more linear equations that are considered simultaneously at the same time. So basically what we're talking about now, instead of just putting one line on a graph, we're going to put two lines on a graph. And then the point of intersection will be the point where two or more lines cross. So example 1, graph the following lines on the same grid and identify the point of intersection. So we've been practicing graphing lines, and I've been telling you that you need to make sure you get nice straight lines. And this is really why, because if your line is going a little bit crooked, it'll be much harder to tell where the two lines cross. So when we look at the first one, y equals 1/2 x minus 3. This is in y equals mx plus b form, and we know how to graph these. This is what we've been practicing. So I know that the y-intercept is -3, so I'm going to go there. And then I'm going to go up 1 and over 2, because the rise over run is up 1 over 2. And I would continue to do that until I have a nice straight line. So that is y equals 1/2 x minus 3. The other equation, when you look at this, it's not really in standard form. It's just in this other form where we have x plus y equals -6. So I would rather see that in y equals mx plus b form. My y-intercept is -6, so 1, 2, 3, 4, 5, 6. And then the slope, remember that there is a slope in there. It's -1 over 1. So that means from -6, I would go down 1 and to the right 1. There's a line in y equals -x minus 6. So what this was, that is a linear system. We have just graphed a linear system. Two lines on a graph make a linear system. But what we're actually looking for, the whole point of doing that, is that we're looking for the point of intersection. This is called the solution. So it's the solution to the linear system. We want to know where the lines cross. So is it ever important now that you remember that the ordered pair goes x and then y? So we need to know what this point is over here. So that looks like -2 if I go that way, and down 1, 2, 3, 4. That would be the ordered pair -2, -4. So we would say, therefore, the solution is -2, -4. And this is the solution to a linear system. So believe it or not, when I teach grade 10 academic math, my very first unit with my grade 10 students is called linear systems. And this is exactly what you would do in grade 10. So if you're good at graphing lines and you know exactly where they go, it's going to really be to your advantage. So another thing it's asking you to do down here is check your solution. So we can do a formal check, a left side, right side check, to make sure we actually have the right answer. I have two equations. So the first equation I have is y equals 1/2 x minus 3. And the second equation I have is x, I'm just looking at the original equation, x plus y equals -6. So if this really is the answer, we have to show that this point would actually work for both equations. If we just prove that this point is on one line, that means the point could be, anywhere along the line. That's not enough. We have to actually prove that this point is on both lines, because that would mean it's actually the point of intersection. What I'm going to do, I'm going to break this up into left side and right side. What that actually means is the left side is the left side of the equation, or the left side of the equal sign. And then the right side is the right side after the equal sign. So now that I've broken up the equation into left side and right side, I'm going to sub in -4 for y, because that was my answer. And I'm going to sub in -2 for x. And I'm checking to make sure I got the right answer. So the left side is just -4. The right side is going to be -2 over 2. That's -1. Minus 3, and that's -4. So look at that. The left side's -4, and the right side's -4. So the left side equals the right side. So what we've just shown is that this point is actually on this line. We have to do that again, though. We're going to break up the equation into left side of the equal sign, x plus y, and right side is just -6. So when I sub in my x, that's -2, and the y, that's -4, that's -6. So my left side equals the right side again. What that means is that this point is actually on this line as well. So therefore, we have proven for sure, we know already that our answer is correct. So therefore, -2, -4 really is the solution. So let's look at example 2. Graph the following lines on the same grid and identify the point of intersection. So this already looks like equals mx plus b, so I'm just able to graph that line and go up to 5, 2, 3, 4, 5, and then down 1 and over 1. That is y equals -x plus 5. Then I have this other line, y equals -x minus 1. That way I'm able to see the y-intercept is -1, and then the slope is -1 over 1. So it actually has the same slope as the other line. So if I go down 1 and over 1 and I continue that pattern, I have my second line. That's y equals -x minus 1. So these two lines actually have the same slope, and they do have different y-intercepts, but these lines are parallel. So the question is, identify the point of intersection. Where do these two lines cross? Well, we've been taught that parallel lines are never going to cross. So how are we going to say what the solution is? If they don't cross, there's actually no solution. Example 3, graph the following lines on the same grid and identify the point of intersection. So maybe with this one, this equation here is in standard form. I think I'll rearrange it because that's going to help me graph this. So I'm going to leave the y term where it is. The 2x becomes negative and then the 6 becomes positive because I'm going to move those to the opposite side. I have to divide everything by 3 because I haven't really simplified and isolated the y yet. If it's 2/3, I would definitely just leave it as 2/3 because that's a rise and a run. But 6 divided by 3, that's just +2. So I can graph that line. I can go to 2. I can go down 2 and over 3. And that's y equals -2/3 x plus 2. And then this one, I just want to remind you, there's another way we can graph. So remember intercepts? What if we let the x equal 0 and let the y equal 0? This is just a reminder. You could also get the y by itself and do the exact same thing as we did over here, but if I let x equal 0, 4 times 0 is going to just be 0, and then 6y is going to equal 12. So then I'd have to divide both sides by 6, and so I get y equals 2. That's a y-intercept, it'd be right here. And then if I let the y equal 0, I am just left with 4x equals 12, and then divide both sides by 4, and I get x equals 3. So that's just a way to find the two intercepts. You let the x equal 0, let the y equal 0. If the y is 0, then you're going to find the x-intercept. If the x is 0, you're going to find the y-intercept. So if y is 2 and x is 3, that's kind of weird, right? We actually get the exact same line. So if I had to graph that line, I would end up just graphing another line right on top of the other one. Those are identical lines. If we had to rearrange this one and got the y by itself, just like we did it over here, we would have seen that those two equations would have been identical. So the question is, identify the point of intersection. Where do these lines cross? So the idea with this, if you actually have the same line and then you have another line that's exact same on top of the other one, those lines are actually crossing or touching in many different places. And then we could go in between those, and we could go in between those points. So in this case, the solution is infinite, or there's an infinite number of solutions. And those are the 3 possibilities that we would have. So if we graphed 2 lines, they could actually be the same line twice, and there's an infinite number of solutions. We could have parallel lines, and then there is no solution. But most often we end up with 2 different lines, and then there would be one solution where they cross. So example 4, it says Mike wants to join a ski club for the winter season. He's considering the two options shown. So there are two options that we see here. We have costs and we have number of visits across the bottom. It looks like two different lines here. One starts at 0, one starts at 100. The one that starts at 0 looks like it's going up. It has the slope is more steep. And the other one, the slope is not as steep, the dotted line. When I read a little bit further down here, I know that these are called the standard plan, that's the dotted line, and the frequent extremist is solid line. So it does say write an equation for each line. Okay, so important is finding the slope of each line. I know the B for the dotted line, that the standard plan, and the B is going to be 100. But what's the slope? So I'm looking for a nice clear point, and I don't really see one until I get to here. So for that dotted line, what if I had a rise over run? And I'm going to look at the rise. It goes from 500, but be careful, it only goes down to 100. So that's a rise of 400 and a run of 10. So for that dotted line, that's the standard plan. The slope would be 400 over 10. 400 divided by 10 is 40. Now we have to find the slope for the solid line. I do see a lot of clear points here with a solid line. So we could even just write our little right triangle in here. Looks like 100 over 2. A larger right triangle would be 500 over 10, which is 50. That's the same thing as 100 divided by 2. So I have a slope here of 50. And with the other one, I had a slope of 40. But what does that mean? 40 what? 40 what? So we're looking at cost per visit. So it'd be $40 per visit if he's going to go skiing. And the other line would be $50 per visit. You could write an equation for each line. The frequent extremist, which is the solid line, has a slope of 50, so the cost is $50 per visit, but the y-intercept is actually 0, so you could say plus 0, or you could just leave your equation like that. For the standard plan, the cost is going to be, we figured out the slope is $40 per visit, but there was an initial fee here of $100 for the standard plan that you would have to pay at the beginning. So this is a common example. This is a linear system, but it has a meaning to it. So this is representing a real life situation. The question would be, which plan should he choose? And then some students will say things like, oh, the frequent extremist sounds cool, so he might choose that. The idea is, well, it depends. If Mike isn't going to go skiing very often, do you notice how the solid line is less expensive? It's lower all the way up to 10 visits. But if he's going to go skiing a lot, let's say he's going to go skiing like 30 times, then the dotted line, then the standard plan ends up being the one that is lower. So it's going to be less expensive in the long run. So it really depends. How often is he going to go skiing? So it looks like Mike is going to have to pay every time he goes, no matter what. It's just which plan makes more sense for him. If he knows he usually only goes skiing about 5 or 6 times, then he should definitely choose the frequent extremist. But if he ends up going quite often, he might not want to pay the $100 up front. But then in the long run, he is going to actually end up paying less for the standard plan. So the interesting idea is that when the two lines cross, right here, they're crossing at 10 visits, right there. 10 visits, when they cross, both of those plans cost $500 if you go 10 times.